Semi-structured data refers to information that doesn't fit neatly into traditional relational databases, but still has some organizational structure, such as JSON or XML formats. For example, here's a JSON block showing song data with nested user and song details. Querying nested fields within these formats presents challenges due to their hierarchical nature, making direct access more complex than in flat tables. However, this data can be handled without rigid predefined schemas, using efficient methods for storage, processing, and querying nested information. This approach is crucial in today's data-driven world, offering flexibility and scalability for modern applications. JSON, or JavaScript Object Notation, is a text-based format designed for representing hierarchical data. It uses nested objects and arrays to structure information in a readable way. Here's a simple example of a JSON object with nested structures. A user object containing name and an array of orders. Parquet is a columnar storage format specifically designed for analytical queries. It stores data by columns rather than rows, which enables better compression and faster data retrieval. Unlike row-based storage, where data is stored contiguously by rows, columnar formats like Parquet organize data by columns, improving efficiency for analytics. Parquet excels at handling nested structures through schema evolution, allowing flexible data schemas that can change over time without breaking queries. This makes Parquet perfect for big data tools like Apache Spark, Presto, and Trino, which rely on efficient querying of complex nested data. The variant data type is a flexible column type used in SQL databases like Snowflake and PostgreSQL, specifically through JSONB, for storing semi-structured data such as JSON objects. Variant enables querying nested fields directly within SQL without the need to flatten or restructure the data, making it highly efficient for complex queries. Here's a Snowflake example showing how to query nested fields. Select data key.subkey from table. This syntax allows direct access to nested JSON elements. Key fundamentals include type coercion, which automatically converts data types as needed during queries, and path navigation, using dot notation to traverse nested structures. A standout feature is Snowflake's dynamic tables, introduced in 2025, which automatically refresh JSON data in real time, ensuring queries always access the latest information without manual intervention. Path-based access allows you to navigate through nested JSON structures using dot notation for keys and brackets for array indices. For example, to access the user's name, use dot notation, user.name. For array elements, use brackets, user.orders0amount to get the first order amount. Flattening nested JSON converts hierarchical data into relational tables. Apache Spark's explode function expands arrays into separate rows, making nested data accessible for SQL queries. In-place queries use the variant data type to query nested fields directly without flattening. For example, where variant call user.orders0amount50 filters records based on nested values. MySQL uses the JSON extract function to query nested JSON fields. For example, JSON extract JSON-call.user.name retrieves the user's name from a JSON column. PostgreSQL uses the NASH operator for JSON path access. For example, JSON-user extracts the nested name field from JSON data. Indexing nested fields is crucial for performance when querying semi-structured data. By creating efficient lookup paths, indexing allows databases to quickly locate specific nested values without scanning entire datasets. Snowflake's search optimization service automatically indexes variant columns, dramatically speeding up queries on complex nested JSON structures. Vectorized processing optimizes nested JSON querying by handling data in batches instead of processing each row individually. This approach reduces computational overhead by minimizing function calls and memory access patterns. For nested structures, vectorization means operations on entire arrays of values happen simultaneously, leading to significant performance gains. Columnar storage optimizations have transformed nested JSON performance by organizing data vertically by columns instead of horizontally by rows. This approach allows queries to read only relevant columns, skipping unnecessary data. Formats like Parquet have evolved with improved metadata handling for nested structures, enabling faster scanning and compression of complex JSON data. In-memory processing represents the pinnacle of performance optimization for nested JSON. By keeping frequently accessed data in RAM rather than on disk, queries execute instantly without I/O bottlenecks. When combined with columnar storage and vectorized processing, recent advancements have achieved remarkable results. According to Gartner reports from 2024-2025, these optimizations have reduced query latencies for nested structures by up to 50%. Amazon leverages Parquet and variant data types in Redshift for e-commerce analytics. By querying nested JSON fields from user events and clickstreams, Amazon processes billions of records daily. This approach improved recommendation accuracy by 25% in a 2024 case study, enabling more personalized shopping experiences. Tesla processes vehicle telemetry data in JSON format using Databricks Delta Live tables. This semi-structured data includes nested fields for battery diagnostics and sensor readings. By querying these fields, Tesla enables predictive maintenance, reducing vehicle downtime by 30% in a 2025 pilot program. PayPal uses Snowflake's variant data type to query nested transaction JSON in real time. This enables sophisticated fraud detection by analyzing complex transaction hierarchies and patterns. A 2024 case study showed this approach reduced fraud by 40%, protecting millions of transactions daily. The merging of data lakes and warehouses into lakehouse architectures represents a major trend in data management. This convergence eliminates data silos by combining the flexibility of lakes with the structure of warehouses, using Parquet as the backbone for efficient storage and querying of semi-structured data. According to IDC, this shift is accelerating rapidly. By 2026, 70% of organizations are expected to adopt lakehouse architectures, driven by the need for unified data management and cost-effective analytics. AI is transforming how we query nested data. Machine learning automates schema inference and optimizes queries for nested fields. Large language models integrated with SQL engines now support natural language queries, allowing users to ask questions like show all orders over $100 for user Alice without writing complex SQL. With the surge in IoT data, edge computing is rising for querying nested JSON directly at the source. This approach reduces latency by processing data locally rather than sending it to the cloud. Platforms like AWS IoT Greengrass enable real-time querying and analysis of nested structures in IoT environments. Sustainability is becoming a key focus, with efficient Parquet compression reducing energy consumption in data centers by up to 40%. Advanced encoding and compression methods, like ZSTD, significantly lower storage costs and environmental impact while maintaining fast query performance. Industry leaders offer valuable insights into the evolution of semi-structured data handling. Snowflake CTO Benoit Dageville emphasizes how Variant democratizes JSON querying, transforming complex nested structures into simple SQL operations that power the lakehouse revolution. Databricks CEO Ali Ghodsi highlights Parquet's nested support as crucial for data unification, predicting that future AI will make querying as intuitive as natural language. Apache Arrow founder Wes McKinney describes the inevitable shift to columnar formats like Parquet for JSON, enhancing performance for AI workloads. Key statistics reveal widespread adoption and significant improvements. 85% of Fortune 500 companies now use Variant for semi-structured data management. Queries on nested JSON are 5 to 10 times faster than traditional ETL processes. The global semi-structured data management market is projected to reach $50 billion by 2027. Looking ahead, the future of semi-structured data leans towards autonomous, AI-enhanced systems where handling this data becomes seamless, providing faster insights from unstructured sources.